So the Guana Water Quality Project started out of concern and support from the community due to the river reopening for oyster harvesting and new developments popping up in the north part of the system. There was this need to establish a baseline for water quality. So then I came along and was awarded the Graduate Research Fellowship through the Friends of GTM to look into the human impacts and potential pollutant sources in the system, as well as the spatial and temporal water quality trends. And then also looking into the management practices within the system and how that affects water quality, specifically looking at how the dam is controlled. So most of you probably already know this, but just a quick overview. The headwaters of the Guana River estuary start in the Ponte Vedra area. North of Michlers. This is very heavy residential business area, and it's managed by St. Johns County. And then the lake portion of the system is south of Michlers, and this is managed by FWC. So then we have the river system south of the dam, which is kind of managed by GTM and used, both the lake and the river system are used for educational purposes. And then Guana Dam, like I said, is managed by FWC, and they use the dam to control water levels in the lake as well as salinity levels. And they do this by inserting these swing gates, which you can see down here. Depending on how they insert the gates, allow them to recharge, put water into the lake, or discharge, let water come out of the lake. And there's always a little bit of two-way flow going on, but they can, prevent a lot of that flow from happening with the use of those gates and boards. So when we're thinking of these water control structures, usually behind the impoundment, so the lake, we would expect to have poorer water quality due to increased residence time, as well as like the flow being slowed down by these control structures, and then a hindrance of tidal exchange and flushing. And so because of that, we would expect to see poor water quality conditions in Guana Lake when it comes to nutrients and such, and algal biomass. And then during these periods of discharge with the dam, we would expect to see, or I expect to see, higher nutrients and phytoplankton biomass in the river, especially near the dam area. And then during periods of recharge where water is being let into the lake, we'd expect higher salinity levels in the northern part, or pushing farther north in the lake, as well as a decrease in the lake's influence on the river. And then the lake's response to these recharges, I'm kind of unclear on that, because they are allowing more water to come into the system from the river to come into the lake, which would dilute what's in there. But at the same time, they're not letting that water out of the lake, so they're preventing the water from going back into the river. So there's not as much exchange going on, which would lead to those poor water quality conditions. And how we're going about this, we have monthly nutrient runs where we collect samples at 10 sites, 4 in the river and 6 in the lake. And then these samples are sent off to labs for analyses. And then of course we do like in-field parameters as well using a handheld. And then with my spatial surveys, we've created this flow cell system where we have a handheld, the ProDSS handheld, hooked up so that we can traverse the water system and get readings on all these parameters, as well as GPS locations, so that I can take that and throw it into GIS and interpolate the data to create these spatial maps. And then just a quick water quality overview. So I know there's a lot going on here, but what I want to point out, so we're starting on the north end, Michlers, and going to the South Point GR3, which would be in the river. The main thing here, this is the 3.5 years of nutrient data that we've collected so far. And what we're seeing is greater variability in the lake and more extreme values in the lake as well. And these are the main parameters that I'm going to be looking at with you guys today. And then that's, I ran some non-parametric analyses tests just to compare the lake sites, or the lake as a whole, to the river as a whole. And with this, the lake is on the top, and the rest of the graphs will be like this, with the rivers on the bottom, starting north to south. So our most northern point to our most southern point. And what I did see were that there are definitely higher concentrations of nutrients, specifically here nitrogen, in the lake than in the river. Significant differences with the lake average of 1.72 milligrams per liter and the river averaging 0.80 milligrams per liter. And then our problem sites, our peak sites tend to be GL2, which you can see here, and then the lake mid site in the lake. And then within the river, we're usually seeing higher concentrations of nitrogen with the river north side, which is our most northern river site that's closest to the dam. And then here in the river, we have like a threshold set, and then the nitrogen concentrations do exceed that threshold quite frequently through the period, the sampling period. And then we see the same thing with phosphorus. We have higher concentrations in the lake in comparison to the river. These are significant. The problem sites here again, or the peak sites, are GL1 and the GL2 site, which are very northern in the lake system. And then the river occasionally exceeds the threshold that's set for it, but the phosphorus doesn't tend to be as prominent in the river. And then the same story with chlorophyll, an extremely large difference between the lake and the river. We have lake average of about 24.25 micrograms per liter. The problem site, again, GL2, this tends to be a trend. GL2 has some issues. So the river peaks, river north again, we're seeing the high peaks in chlorophyll, which is our most northern river site. And then both the lake and the river continually exceed the thresholds that are set. So just kind of looking at dam status and salinity, here we see this in graph form. And if you look here, the black lines indicate a period of lake drawdown. So this is when FWC draws down the lake in the winter time or around the winter time to mimic winter drought conditions of a natural shallow lake. And then the gray periods are discharge periods. So you can kind of see where when the system is in discharge, so you're going to have your river sites up top, your lake sites down the bottom, so higher salinities, lower salinities. And during these discharge periods, you can see where the water gets a little bit fresher. And then in the recharge periods, when saltier river water is going into the lake, you see these increases in salinity in the lake. And then we can also look at this through the spatial surveys that I've done. So you're going to see and it didn't start where I wanted it to. I made this GIF. I wish I would have made it a video so I could stop it. Anyway, the red is recharge. So that's river water going into the lake, and the blue arrows are discharge. So you have that fresh water pushing down from Michelers. So I'll just let it run through one more time so you can kind of see, but it just gives you a good idea of like a good visual of the range shift of the salinity concentrations in the system. So then I wanted to go over two events that occurred in the system. One happened during recharge and the other happened during dam discharge, and just kind of see how the system responded to these events. So this first one here happened while the dam was at the end of the discharge, so at the end of the annual drawdown, and you can see here the mud exposed at 6 Mile Landing, and this is around GL2. These are mud flats. This isn't water. This is all mud. It was really windy this day. So there was a lot of mixing going on. The waters were really turbid, a lot of that sediment getting mixed up. And the result of that was high peaks in nitrogen level, high peaks in nutrient, as well as chlorophyll. But here we had high peaks in nitrogen levels with in the lake. In comparison to the previous month, there was like an increase of 251% increase in nitrogen concentrations. And then similar increase we had, well, not similar, but we had the increase in the river as well. And then similar with phosphorus, these peaks in the lake, and not much going on in the river there. And then the same story with chlorophyll, high peaks of increases from the previous month here, especially with our GL2 site. And then not much going on in the river sites. And then I so I did spatial surveys, and this is looking at the chlorophyll RFUs during that time. So March would have been the time of the recharge starting. So the nutrient run, which the data we just looked at, the nutrient data, would have been while the system was still in discharge. And then when I did my spatial survey, which I usually try to do like within the same week, the system was now in recharge. So you can see those high concentrations of chlorophyll here in the north end, the GL2, GL1, higher concentrations in the lake, and the river not as impacted as much as the lake. So we're in recharge, so we're pushing river water into the lake and we're holding it there as best we can. There's always going to be a little bit of two-way exchange of water going on near the dam, but not as much as like when it's in recharge. And then you can see here the month after the event, it's kind of a more uniform distribution of chlorophyll concentrations. The river seems to be a little more impacted. I know. So in this month, the river was in recharge. There were 3 gates in recharge pushing water in. And this month, there were only two gates in recharge pushing water in. So you didn't have as much going in to the system. And then I also, I went ahead and I compared RFUs from the handheld to what we send off to the lab for chlorophyll, just to see if they're like what the relationship was there. So I ran a linear regression, and as you can see, the relationship's not that great. So I can't say, well, if you see this RFU, then you can compare it to this microgram per liter, but you can look at these and see where you're having these higher concentrations of algal biomass. And then the second event, hopefully I'm doing okay on time. Okay, so the second event occurred during dam discharge, and this was August 2020, and was a vegetation removal north of Meichlers near Sawgrass area, where they went in and they kind of widened out this canal and moved a bunch of vegetation. As you can see here, this is Meichlers, A1A and Meichlers. And you can see all this vegetation coming into the system. We have like some invasives, water hyacinth, duckweed, just all this organic debris just coming straight into the system, nothing really stopping it. And what ended up happening was we saw spikes in nutrients and bacteria and chlorophyll at Meichlers how we have never seen before. Specifically with nitrogen, there were great peaks at Meichlers of like from the previous month, 477% increase in nitrogen levels. We saw the rest of the lake sites also increased, and not so much in the river here. So you're looking at this right here. There wasn't much of an increase, a very small increase overall in the river. Following the event, there were, however, very high levels of nitrogen in the river. And then same story with phosphorus. There was an increase from the previous month at Meichlers, an increase overall in the rest of the lake sites. And then the river site actually decreased from the previous month. So it doesn't seem like the river was that impacted as far as phosphorus goes during that event. And then with chlorophyll, same thing, Meichlers, which is historically very low for chlorophyll concentrations, saw a over 1,500% increase from the previous month. The lake as a whole, the rest of the lake sites actually saw a 22% decrease in chlorophyll concentrations from the previous month. And then there was a slight increase in the river sites with chlorophylls, the highest being at the river north site. So then again, I took the chlorophyll spatial surveys that I did and kind of took a look. I'm missing I'm missing July, which was the event happened in August, which the dam was in discharge. So I'm missing July spatial survey because my pump broke, so I didn't have it. So I just threw June up there just to see, kind of a comparison and looking at the recharge. So during discharge, the event happened up here at Meichlers. There are higher concentrations all throughout the lake. We can see a little bit of the higher concentrations here in the river, and not GR3 doesn't really seem to be, affected at all during this discharge period. But then in September, we seem to have more concentrated spots of higher levels of chlorophyll A, specifically up here by GL1 and then by Lake Mid. And then it does look to, the river does seem to be a little more impacted here. We also have to take into account that the river was in discharge, and then we had a very high rainfall that month as well. I think a storm came through that month. So we kind of have to think about that too. And I just threw up October just to show, because we were still in discharge during that period, just to kind of see, what that looked like. And then that's it. What's next for Guana? I have a lot of analyses to do. I have a lot of work to do, a thesis to write. And then for the Guana system, the Science Collaborative is starting, and I think Ashley is presenting on that next. So I'll let her do all the talking about that, and I am done. But just to thank you guys, especially the Friends of GTM for giving me this fellowship. Has been amazing, and FWC, which I don't think any of them are here, but I couldn't do this without them. So that's it. Thanks.